Hi guys and welcome back. In this lecture we're going to do something very exciting. We are going to create a circle detector, and from the circle detector we are basically going to calculate distance from that circle. Okay, so today we're going to approach things a little differently and a little bit more efficiently than before. So first of all, what we're going to do is we are going to use the Vision Express VI. So look for your Vision toolbox. Click Vision Express and Vision Acquisition. Now you can see from this, it's going to make things very easy compared to what we were doing before. But what we did before was just to show you how to get things on a more lower level. So we're just going to wait for Vision Acquisition to initialize. So this VI is basically to initialize your webcam, and it also captures your data and makes it very easy for you to acquire your video. Okay, so select your camera, you can click play. And you can see I'm over here. Okay. So once that's working, click next. And now you're gonna go and click continuous acquisition with inline processing. So this allows you to basically capture video in real time. Over here, we just have a single acquisition, and this is a finite acquisition. So you can specify how many frames you want to acquire, maybe 5, maybe 10, maybe 100. And then you have finite acquisition, so it captures all the video first, and then it does the post-processing. Okay, so we choose continuous acquisition with inline processing, and we want to acquire the most recent image. If we have to acquire every image, we'll need to buffer it. But when you buffer it, there's also going to be some lag. Okay, so click next. And basically over here, you don't need to change much, only the resolution. If you want it to work fast, we go to 1280 by 720 JPEG. So I'm going to choose that one. You can test it out also. Seems to be working. Press stop and then next. Okay, if you want to enable image logging, so if you want to capture your datasets, you can click that, but for now we're not going to do that. Click next. And then we basically want the frame rate. Image number can also be useful in this case. So let's do that. Click finish. And then we wait for it to generate. Now, if you double click on this, it automatically creates our image box. Press play. And then we zoom out. Press shift. And then zoom out. Okay, so as you can see, we have acquired video, and it's very easy to acquire video in LabVIEW. So basically, we're going to add in our Vision Assistant VI block. So let's go ahead and do that. Okay, so just make this a bit larger. We want to add our frame rate. Create indicator. You can make this something fancy if you want. So let's make it a little bit of a meter. And then we make this from 0 to 30 frames per second. And we take that over there and then we link it up to our frame rate. So now if you click play, you can see our frame rate shows over there and it looks quite nice. Okay, so getting on to the important stuff. So go to Vision in Motion, click on Vision Express and then Vision Assistant, and then place it within the loop. Okay, so to speed things up, what I'm going to do is I'm going to include the range detection algorithm basically pre-made. Now we are going to go through each and every step, but if you want to make it yourself, free to go ahead. Okay, so let's go through what's actually happening, right? First of all, we have the original image. You can actually test this in Vision Assistant by itself. So we're creating an image buffer first. So this is just so that our output image will output the original image, okay? So you save it to buffer 1. Then we go ahead and we do color plane extraction. It basically makes it to grayscale. And then we threshold the image. Now thresholding, as I said, makes it binary. If things are below the certain threshold, it becomes red or it becomes black or vice versa. Then we do the particle filter. So let's just go ahead and show you what's happening here. So here I just extracted the red plane for now, but you can select another one that best suits your algorithm. Then we go into threshold. And I chose clustering because it clusters the most black pixels together, especially for a circle. Then I did a particle filter. Now in the particle filter, scroll down all the way to Hayward circularity factor. And that basically searches for anything that looks like a circle. When you're prototyping this, I want you to basically download a picture of a circle and print it out. And that circle will be used as your marker to detect. Okay? So everything stays the same besides make this 2 and select this on keep. So that'll keep all our circles inside. Then we use advanced morphology to basically get rid of all these speckles. Now you can see in this picture, I don't have my picture of the circle, but let's take this for example, right? Now in advanced morphology, we want to remove all the small objects, like I said, and I use 12 iterations. And then we use the lookup tables. Lookup table basically on equalize, it converts your binarized image into a grayscale image. So whatever, it just maps it onto different color spaces. And then we do shape detection, right? The reason why we're using shape detection is that it works much faster than using plain old circle detection. Circle detection was very, very slow, so that's why we use shape detection. So in contrast, circle detection works at 8 frames per second, and shape detection works at around 30 frames per second. We can confirm that in a second. So let's take this as an example. I'll show you a real circle that we'll create. So this one, say it's our temporary circle. You can choose our shape as circles and rotated, scaled as well if you want, or occluded. You can select that depending on how far you want to move your circle. And max radius I put as 500 and minimum radius as 3. Okay. And then we open up our image buffer. And this is the one we saved right at the beginning. And we press retrieve. So we're retrieving that buffer. Okay, so once you're done with that, select controls. And we want to see our circles, image buffer as well. Number of matches, maybe. We can optimize the code for parallel execution. Before we do that, let's just check how fast our algorithm is. So you can see our current image is running around 20 frames per second, which is not bad compared to 8 frames per second. Click on details, and you can see which one is using the most. So advanced morphology is using quite a bit. So then select controls, and then finish. And now we just wait for our vision assistant to generate. Okay, so that was really quick and easy. So now what we want to do is we want to link up that. Delete. And then we put this in, our image in. You can put image out as well. Or image buffer. Okay, let's see what's happening. Let's create our indicators for this one here. Okay, let's see what we get now. Okay, so I'm going to show my picture of the circle. I have it here on my iPad. Over here. And then you can see right over here, it detects our circle with a radius of 109 pixels. Now, whenever there's a glare on my iPad, you can see it doesn't detect, but I'm going to try and keep it at an angle. Okay. Now, what we can do before we finish off this algorithm is that we want to overlay the images on. So basically, we want to overlay the circle's information or the circle region of interest onto our image. So basically, instead of unclustering this cluster or array, we're basically going to use the function that I've made. So basically, I want you to create a project from there. So create a blank project, and we want to add this VI. Okay, so the reason why we open up this as a project is so we can introduce sub-VIs, which are basically functions in LabVIEW. So let's just save our project, and we're going to call it distance calculator. Click next. We save the project, and then we're going to save the VI. Now you may not have overlay circle in your project. So I want you to go and say add file. And then in the project files that I gave you, you click on overlay circle and add file. I already have it in here. So basically in what this function does, right? It takes in your circles that you get from the shape detection, takes in your image as well, and does an overlay. But it also unbundles and converts the variables. So it takes position and then it unclusters that. And basically what we're doing is we're taking the x coordinate and adding the radius to it. So we're creating a rectangle bounding box, which is what this thing requires. This oval requires a bounding rectangle for which it is bound. We're taking the position and we're basically adding and subtracting the radius to it. So then we get the bounding box shape. So that's what's happening in that. Save. So drag this into your VI and we're going to take it in. So you can see how simple it is. Once you got your function, basically simplifies your code. Okay, so let's see what we get when we press play. And as you can see, we have our overlay we have a circle overlay and it's doing quite well. Let's take a look at our radius. Gets bigger when we go closer and gets smaller when we get further away. Okay, so we are not yet quite done. I promised you that we would overlay distance. So I promised you that we would get distance. So let's do that. Okay, so let's look at how we calculate distance from a bunch of pixels. This is a paper that I've written. It's a 3-step vehicle detection framework for range estimation using a single camera. If we go over to range estimation, this is a simplified equation. So obviously this equation is calculated from using trigonometry. We use our angles and then from here we have d, which is our distance to the camera. F is the focal length of the camera. X2 is your actual object size. And X1 is basically the projected object onto the image plane. Okay, so you can either do it this way or you can do it empirically by basically measuring the distance to your camera and from there get a constant that you can use to calculate your distance. Okay, so what we're going to do, we're going to first convert our array to cluster. We're going to unbundle a cluster. Then unbundle it again. Okay, so we got position, radius, and score. So we want to convert our radius into distance. So the bigger our circle is, the closer it is. So the smaller it is. So we're going to take 70, create our constant, which is 70. And then we take this one out and see if we get our distance. So as you can see, it increases, and then if you come closer, get that right, it starts decreasing. Okay, and so as you can see, we have measured distance. Now let's just add a nice graphical thing to it. A graphical slider, horizontal filler, and then we want, say, 0 to 70. Can make this nice and big. Okay, so first we have to hook this up also. Just make it a indicator. So now we're going to see if this thing folds up according to distance. Okay, so let's see how it works. And if you bring it closer, you can see it moves right according to my circle. And there you have it, your very own distance calculator. Now, it may not be that robust, but it all depends on your algorithm. For those who are struggling with this, the whole VI will be in the resource section of this course. And for those who did it, well done. If you just make sure you don't have anything in the background that may confuse it with a circle. And there you have it, guys. See you in the next lecture.